Hello, hello. Let's hope I can get through this video without making any mistakes. It's been a long day of conferences. So this video is going to be on linear and absolute value function transformations. So there's going to be 15 problems. This might very well be a lengthy video. The first 5 problems, conferences, like I said, a lot of talking. The first 5 problems are going to be on linear, and the last, so 1 through 5 are going to be linear, and then 6 through, or no, it's actually not 15 problems, 6 through 13 are going to be on absolute values. So if you want to skip straight to absolute values, skip ahead in the video. Problem 6 that I'm going to go through is going to be the first absolute value problem. So for all of these, there are going to be certain functions that we are going to want to let f of x be. We're going to be transforming specific functions. So for problems 1 through 5, we're going to let f of x be equal to negative 2x plus 1. So that's a linear function. So we're going to start off over here with f of x equals negative 2x plus 1. What we're going to do is we're going to do one transformation to that, and we're going to do a vertical stretch by 3. Now, vertical stretch, if you've maybe seen in some of my other videos, a vertical stretch means you're going to multiply the entire function by the value. We're going to multiply the entire function, in this case by a, and in this case a is 3, so we're going to multiply the entire function. So I would really, I'm trying to, can't make anybody do it, but I'm trying to get my students to show all their work, and the step that you should show is we're going to multiply the entire function f of x by 3. Now, what is the entire function? The entire function is negative 2x plus 1. So if I'm multiplying the entire function, I need to put parentheses around the entire function, negative 2x plus 1, and I need to multiply that entire function by 3. So this would be the transformation, right? That is what we are actually doing to it. We are multiplying the entire function by 3, thus vertically stretching it by 3. So this whole piece has now been transformed into a whole new function, g of x. We're going to call it g of x. That's usually the next one we go to, right? A, B, C, D, E, F, G, and then after G, H. Mathematicians are so brilliant. Just using the alphabet, right? So F, G, so g of x. Now, what do we need to do to simplify this? So we need to multiply everything by 3. We need to distribute it. So 3 times negative 2x, negative 6x. 3 times positive 1 is positive 3. That is f of x transformed with a vertical stretch of 3 to create a new function g of x. All right, whenever you transform a function, you get a whole new function. It's no longer f of x. It's a whole new function, and we're going to call it g of x. Again, because g comes after f in the alphabet. Okay. Next one. Still starting, right? Problems 1 through 5, we're using this function. So still starting with f of x equals negative 2x plus 1. This problem is telling us to do 2 different transformations, but we're doing 2 different transformations at once. So we're going to vertically shift f of x down 2 units and reflect it over the y-axis. So, come back to my handy notes, because I would love to have handy notes. If you want to, pause this video and you can write down all these notes. shift down means that we're going to add a number that is negative, which means just subtract the number. So we're going to subtract the number for moving it down, and then a y-axis reflection means to multiply, oh gosh, long day, means multiply the input by a negative. It means to multiply the input by a negative, okay? So we have f of, we're going to multiply the input by a negative, but then we are also going to subtract off 2 to the whole function. Adding a negative 2 is the same as subtracting 2 off of the whole function. So this is where it gets a little interesting. Up above, we multiplied the whole function, so we put parentheses around the whole function. But for this problem, we are multiplying just the input, the x value, the input, by a negative. Well, are there parentheses around the input? There are not. Because if I just put a negative right there, it'll look like negative 2 minus x. That's not what we want to do. What we want to do is we want to create parentheses around the input so that when I have negative 2 parentheses x, I can multiply it just like I did here by the negative, because I'm multiplying just the input, not the whole function, just the input, and then plus 1. Or no, wait, hold on, that shouldn't be red. Let me, all right, now it looks black, but we're gonna roll with it. So I multiplied just the input by a negative, but this subtraction of 2 is to the whole function. So the subtraction of 2 is the whole function. Well, do I have parentheses around this whole function? I don't. So you actually have to create another set of parentheses around the whole function to subtract 2 off of the whole function. So there's always going to be 2 possible sets of parentheses, or maybe when doing absolute values, it'll be absolute values, but there's an inside and an outside. There's something that is happening just to the input, and then there's something that is happening to the whole function, which is the output. So if this is happening to the input, and this is happening, that minus 2 is happening to the entire output, to the entire function. We're going to subtract 2 off of it. So first things we do is we simplify the entire function after doing a y-axis reflection. So what is a negative 2 times a negative x? Positive 2x. And are these parentheses really doing anything? Well, you know what? I'm not going to skip a step. I'm not going to skip a step. Minus 2. So we simplified the inside. If the inside simplified, I can't do anything more to it. Are these parentheses important? Are they doing anything? They are not, so we can just drop them. And when we drop them, we get this. So now we can simplify and combine like terms. What is a positive 1 minus 2? That is a negative 1. So we get 2x minus 1. And what has happened here is this whole function has been transformed to be g of x. So that is the new function g of x. If it's very important that sometimes there might already be parentheses around the x, there might already be what I like to think of as an inside determined, but when there's not an inside determined, you have to create parentheses around just the variables, just the inputs, not around anything else. But when we are doing it to the whole function, right, you're minusing 2 off of the whole function, you have to create parentheses around the entire function, around everything, and then do it on the outside of those. Okay, let's move on. F of x equals negative 2x plus 1. So this one wants us to reflect f of x over the x-axis and horizontally shift it right 3. F of x equals. So a x-axis reflections means to multiply the entire function, the whole function, by a negative. So the outside of the parentheses, which we're going to have to create, the whole function. A shift right means that you're going to subtract off a number. Always subtract. You're going to subtract off of a number. In this case, we're going to be subtracting a number that is greater than 0. So that means a positive number, because we want to go to the right. So right means subtract a positive number. So on the inside here, we're always going to subtract, but we are going to be subtracting a positive, what we want to shift right 3, a positive 3. Not subtracting off a negative 3, we are subtracting off a positive 3, so minus positive 3. A negative and a minus are not the same. This is not x negative 3. This is x minus positive 3, okay? And then we need to multiply that whole function by a negative. We're going to make the whole output a negative. All right, so whole function. We're going to make the whole function, let me put big parentheses here, negative. All right, so then I have negative 2. Then I'm going to put plus 1 out here. The reason I left space there is because I need to create parentheses around the variable so that I can do something just to the input. Because if I just put x minus 3 there, that looks like negative 2x minus 3 plus 1. But that's not what it is. What it is negative 2 times x minus 3 plus 1. Because I subtracted on the inside of these parentheses, just to the input. I subtracted 3 off of the input, off of the variable. Not off of the 2x. I didn't do negative 2x minus 3. I did x minus 3 to the input. Okay. So before we multiply this negative through, I mean, you could do that first, but I'm not going to. The first thing I always do is I simplify the inside of the parentheses first. So we're still going to have negative parenthesis. Let's distribute this negative 2 through these sets of parentheses. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6, and then plus 1. I need to write it in there. I can still actually simplify the inside still. I can combine like terms. So we actually have negative 2x plus 7. Now I can distribute the negative and multiply it all through, and I will get positive 2x minus 7. And that means this whole thing has now changed to become g of x. So we have an outside, and then we have an inside, just the variable. Over there. Number 4, we're still using the same f of x. Got a hint here, should be h of x now, so that means we're going to have to do a couple things. Okay, and it's negative 2x plus 1. Vertically shift f of x up 5. And then there's this key word that I want to highlight that says followed by. Whoever says English and math are not reliant on each other is not true. You have to understand that the words followed by in this story problem, or I guess it's not even a story problem, but in this problem mean that we're going to do this, and then after we do this, we will then do this next transformation. So we're not doing them at the same time. We're doing one and then the other. That's what followed by means. So followed by a vertical stretch by 2. So first one, we're going to vertically shift f of x up 5. So we're going to take f of x. We're going to vertically shift it up 5. That means to add 5 to the whole function. So that means to add 5 to the whole function. Now, are those parentheses necessary at all? No, they are not. They're not necessary at all. So what we get is just equals negative 2x plus 1 plus 5, which equals negative 2x plus 6. So that would be g of x. But we now have to transform that, because we did vertically shift, we transformed f of x by vertically shifting it up 5, and we've gotten a new function, but now we're going to transform that function by vertically stretching it by 2. So now we're going to vertically stretch this function, and we're going to multiply the whole function by 2, so the whole function by 2. All right. Well, can we simplify the inside? It's already simplified, so let's just distribute, and we will get 2 times negative 2x is negative 4x, and then 2 times 6 is positive 12. And that's simplified, so that will give us a new function h of x, and that's why that hint is there. So we went from 3 different colors, yes I do. We went from the original f of x, transformed that into g of x, and then g of x got transformed into h of x, right? And we did that by here, we went up 5, and then here, we went a vert stretch by 2. The difference between this problem and the other problems were here we did a reflection over x-axis and right 3. So we only did one transformation. It's just we did two transformations, or at least we manipulated it 2 different ways, but it's one transformation. We transformed the function once by manipulating it in 2 different ways. Here, we had 2 transformations where we transformed from here to here and then from here to here. By doing 2 different things, we did one and then we did another, if that makes sense. Hopefully that makes sense. Okay. F of x. So what do we got here? We have the same thing, right? We got f of x equals negative 2x plus 1. We are I'm going to speed up a little bit for this one. and vertically stretch by 2. Then I'm going to highlight my keyword, just like I did in the problem above it, the word then, and then throw in a third transformation, which will be reflect the new function over the x-axis. Okay, so horizontal shift left 3, vertically stretch by 2. So we've done a lot of vertical stretches, but left means that we're going to subtract off a negative number. H is less than 0. We're going to subtract off a negative number. All right. So what we get here is we're going to get f of x minus, but a negative number. So left 3 means that this is actually a negative 3. And then we're going to multiply this entire function by 2. So we're going to have some stuff happen to the outside, and that's multiplying the whole thing by 2. But then we are going to have x minus a negative 3, and then our plus 1. But the important thing is that's happening on the inside. That's happening on the inside. So it needs to be happening on the inside here as well. A lot of parentheses, I know, a whole lot of parentheses. That's why sometimes you might use brackets, like maybe instead of using parentheses here, it might be easier for you to put brackets, which I just call, in math, I like to call those super parentheses. There is a super parenthesis, all right? Same thing. So it still acts like a parenthesis. So let's simplify the inside first. The first thing I'm going to simplify is bracket negative 2. I'm going to simplify this inside. What's minus a negative? That's plus. So this is actually just x plus 3 plus 1. All right, well now I'm going to distribute this negative 2 through. So negative 2 times x is negative 2x. And then negative 2 times positive 3 is negative 6, and then plus 1. Okay. At this point, I might actually change this bracket back to being a parenthesis. So maybe I just change this back to being a parenthesis because I don't need the brackets anymore because all the other parentheses are gone. Let's simplify the inside still. So we got 2 parenthesis, negative 2x, what, minus 5? Negative 6 plus 1 is minus 5. Okay, lots of steps. Almost done though. Let's distribute the 2. So 2 times negative 2x is negative 4x. And then 2 times negative 5 is negative 10. So we've taken this whole transformation and gotten g of x. All right. Now though, I want to transform g of x by reflecting the function over the x-axis. So that means I'm going to multiply the whole function by a negative, and that will give me positive 4x plus 10, and that means I have now changed this to be h of x. So we have gone from, again, we have gone from f of x to g of x to h of x. Right, where we have done here we did left 3 and vert stretch by 2, and then here we did an x access reflection. Two things. All because of the word then, and up here, all because of the words followed by. All right? Fun transformations. Okay. Like I said, it's going to be a long video. I'm working on fumes. Okay. So now we have f of x equals absolute value of x for problems 6 through 9. So for these next 4 problems, we have that. So we're going to start with f of x equals the absolute value of x. Now I like the absolute values because there's a very clear inside. There's inside the absolute value and there's outside the absolute value. So when I do a transformation of up 3, I know that when I add to the whole function, to the outside of this function, I'm just going to add it to the outside of the absolute values. So I add it to the outside. All right, that works for the parent function of an absolute value. Don't have to do any extra parentheses. So we now have, because we've transformed this whole thing, g of x equals the absolute value of x plus 3. All right, and let me highlight, keep track of my highlight. That is a vertical stretch of 3. Okay. Now, don't parentheses, I don't want to say. Because this is the parent function of absolute value, some parentheses that we would normally be using to represent outside, inside, whole function, whole input, we might not have to use them because it's the parent function. That'll make more sense when I do 10 through 13. Anyways, f of x equals the absolute value of x. We are going to want to reflect this over the y-axis and vertically stretch it by 4. All right, so we are going to want to reflect over the y-axis. That means multiply the inside, the input, by a negative. What else do we want to do? And vertically stretch it by 4. So that means multiply the entire function by 4. So I'm going to put my absolute value bars. I'm going to multiply this whole function by 4. And I'm going to multiply the input by a negative. Now, it's really important. You cannot add or multiply into absolute values, and you also cannot just drop them. Notice how the absolute values this didn't change to x plus 3. This is still the absolute value of x plus 3 because it is an absolute value function. If you just get rid of the absolute values, then it's no longer an absolute value function. So this changes to be g of x equals 4 absolute value negative x absolute value. So it is g of x is 4 times the absolute value of negative x. Now, if you have an understanding of what an absolute value does, it makes things positive. So some students are confused, why can't I have a negative thing inside the absolute value? You can have something negative inside the absolute value. That's totally okay. I can do the absolute value of negative 3. I can put something negative inside the absolute value. The point is by the end, it will make it, it will spit it out, it will make it a positive number. But you can input a negative number. But when you actually do the math, like if I input a number into this and do the math, it won't come out negative. At least the inside of this part will not come out negative. It will come out positive, but you can input a negative. So that's okay for that to be a negative x. All right, next one we have f of x equals the absolute value of x. We are going to want to horizontally shift this left 3. And we are going to want to vertically shift it down 4. So horizontal shift left 3, when I'm going left, we've done one of these in this video, and when we're going left, that means that we're going to subtract off a negative 3 to the input. So we're going to have f of x minus, but we're going to subtract off a negative 3 because we're going to the left. And then vertical shift down means we're going to subtract 4 off of the whole function. So subtract 4 off of the whole function. Equals. Okay, well, I already have, not necessarily the parentheses, but I have absolute value bars around my input. So x minus negative 3, and then minus 4. This whole thing is going to simplify to be the absolute value of x plus 3 minus 4. I cannot combine these because one is happening on the inside of the absolute value and one is happening on the outside. You cannot combine or multiply into the absolute values or take things that are inside, just take them out. You cannot do that. What's on the inside of the absolute value is on the inside, and what's on the outside stays on the outside. So this whole thing changes to be g of x. Okay, that's it. That's its function. That's as simplified as it gets. Getting there. We are, well, let me put the parent function in. We're going to horizontally shift f of x right 3. And we're going to reflect it over the x-axis. Then we are going to vertically shift a new function up 3. So let's do the first 2 manipulations, transformations to f of x. So right 3, that means subtracting off a positive number. And then we're going to want to reflect this over the x-axis, and that means multiply the whole thing by a negative. So absolute value bar, x minus, absolute value bar, we're going to put minus our positive 3, and we're going to multiply the whole thing by a negative. All right, so this all changes to be g of x equals negative absolute value bar x minus 3 absolute value bar. I cannot multiply that negative in. I cannot take this negative 3 out. That is it. That is as simplified as it gets. Negative, so g of x is equal to negative absolute value of x minus 3. All right. Now it's going to get a little more intricate. We're not dealing with a parent function. We're dealing with a function that's already kind of been transformed. And that is going to be f of x equals 2x minus 3. Okay, so f of x equals 2 absolute value of x minus 3. We're going to want to horizontally shift f of x left 4. Now, we've done a couple horizontal shifts. That's always minus, and when we're going to the left, that means we are minusing or subtracting a negative number. So that is actually -4. So what we have is f of x -4, and we're subtracting that off. Now I don't need to create an inside, right? I don't need to create an inside because there already is an inside. There's an inside of the absolute value bars here. There's absolute value bars around the input. So I would have 2 absolute value bar and then x minus -4 minus 3. Okay, so let's simplify this. We would get 2 absolute value x plus 4 minus 3. Negative negative is a positive. Minus a negative is a positive. And this whole thing has just changed to be g of x. Right, so that would be the function. Written a little not straight, but I'm tired. Okay, so that's the function. G of x equals 2 times the absolute value of x plus 4 minus 3. Okay, you cannot distribute through the absolute value bars. You cannot do that, right? You cannot subtract into. You want what's on the outside of those bars. What's on the outside of those bars stays on the outside, and what's on the inside stays on the inside. Okay, I actually want to do, I just thought into my head, I better do a little example off to the right. So let's say, what if f of x equaled 2 times the absolute value of 4x minus 3. This would be a little bit different because what I wanted to do is I wanted to subtract a -4 off of the input itself. But there was already absolute value bars, and on the inside there was just the input. But here in this example, there's not just the input. The input is not by itself on the inside. So if I was going to do this same transformation, I would have to put parentheses around the x minus the -3 because it's very important that what we do to the input, what we're doing to the input is happening just to the input. When I do a vertical shift left and I need to do x minus -4, that's happening just to x. That's happening just to the input. It's not happening to 4x. It wouldn't be 4x minus -3. It's x minus -3, and it's 4 times that whole thing, right? And you end up with a very different answer of and then very different answer, right? Very different answer. This distribution ends up changing this to not just be a +3 out there. Or why did I do +3? I meant that to be a 4. Whatever. You get the idea that when it's not by itself, in this case, the x is just by itself, so I don't need to put parentheses around it. But when it's not by itself, you do. Because what you're doing is just to the inside, just to the x. Okay, let's leave that be. Let's call this a separate all right, so let's move on. F of x equals 2 times the absolute value of x minus 3. This video is already long enough for sure. What is this gonna be, like almost an hour, I bet. This is ridiculous. Okay. Reflection over the x-axis. That means that we're gonna multiply the entire function by a negative. So we're gonna multiply this entire function by a negative. The whole function, this whole function, all right, by a negative. So what's really important here, maybe let me use a different color, is we have to distribute this negative, but what's really key is there's only two terms. There's two terms over here inside the parentheses. 2 times the absolute value of x, this is one thing, right? That's one thing. Because if I was to, let's say, 2 parentheses, and if I was to plug in 3, okay, well, that's 2 times 3. Oh, well, that's 6. So really, this term right here is actually just one thing. It's just one number. It's just right now we can't make it one number because we don't know what x is, because x can be anything. So when we distribute this negative, the point of me saying this is when we distribute this negative, it's negative times 2 absolute values of x, which becomes negative 2 absolute values of x. You do not distribute the negative also to the absolute value. You're distributing the negative just to this one term, and then the negative just to the next term. So that would become plus 3. And this whole thing is now changed to be g of x. All right. So the whole point of this is 2 absolute values of x is one term. All right, it becomes one thing. Last 2 examples. Last 2 examples. Okay. So we have f of x equals 2 absolute value of x minus 3. All right, let me throw some paper under here. I hate writing. There's no paper underneath it. I don't know why, but I do. Okay, so we have a vertical stretch by 2 and a shift up 4. So vertical stretch by 2 means you're going to multiply the whole function by 2. And then shift up 4 means we're going to add 4 to the whole function also. So equals. So everything we're doing is the whole function, so let's put parentheses around the whole function. So we're going to multiply this whole thing by 2, and we're going to add 4. Well, there's definitely an order to how we do this. Now, just like we did the negative, we distribute the negative, we're going to have to distribute this 2, and that goes to this and to this, because again, that's one term and that's one term. All right, so we're going to get 2 times 2, which is 4 absolute values of x, and then 2 times negative 3, which is negative 6. And then you're just going to drop down this plus 4, so we have plus 4 out here. All right, and then that equals 4 absolute values of x minus 2, because you combine like terms. So this whole thing has now become g of x. Voila. All right. Last one. I'm so excited. I'm ready to get out of here. All right. Last problem. See, I need to get out of here. I need to. Yeah. Okay. F of x equals negative 2x plus 1. No, that was the last. F of x equals 2 absolute values of x minus 3. Yes. Okay. Horizontally shrink f of x by 3. Ooh, we haven't done a horizontal shrink or stretch yet. And reflect it over the y-axis. Keyword then. Vertically shift the new function up 4. Okay, so we're going to end up with an h of x once we're done with this. So vertically shrink, or no, horizontally shrink is actually multiplying vertical, multiply the outside, horizontal, multiply the inside. So we're going to multiply the inside by 3. We're going to multiply the input by 3. We rephrase it that way, multiply the input by 3. Oh, and we're going to multiply the inside by a negative, the input by a negative, because the y-axis reflection is on the inside. All right, so equals 2. Now, for the sake of talking about how we need to put parentheses around the input when we do the inside, when we're doing it to the input, I will put parentheses around it, even though it doesn't matter. So just for the sake of this, let's pretend that we need to put parentheses around the input so that we can do something to it. So let's put parentheses and then negative 3 . Are those parentheses doing anything? Is there anything happening? Like, are those parentheses doing anything to separate the negative 3x from something else on the inside of the absolute value? Is there anything else on the inside of the absolute value? No. So when x is by itself, unlike this example, I gave, where x is not by itself on the inside, so it was really important for me to create parentheses around the x. But here, there's nothing else on the inside with the x, so it's not necessary for me to put parentheses around it. So what really happens is this just becomes negative 3x, and that's it. So there's no real point. You can, and it's important sometimes to put parentheses around the x, but sometimes it's not. It's redundant. It doesn't actually change anything. So this will actually just become right here, we're going to become g of x. All right, now what it wants me to do is then vertically shift the new function up 4. So g of x up 4 to the whole function. So this is going to be another time where the parentheses are kind of redundant. They're not really going to matter. Is there anything for me to multiply through these parentheses? Is there anything for me to distribute right there? There isn't. So really these parentheses aren't doing anything. So I can just drop them and it'd be 2 absolute values of negative 3x minus 3 plus 4. And then I combine the like terms plus 1. And that would become h of x. So right, we started with f of x. We went to g of x. And we ended with h of x. I feel like this video was definitely long enough and I've done enough problems. Thank you for watching. Thank you for watching. I really do hope this was helpful to any of you who watch this. See you on the next video.